testing? Oh, hey, as you might have guessed, today's lesson is going to be about testing. Now, there's a few things I want to cover today, and one is an overall view of testing and the testing process that happens not only in a school setting, but in an industry setting or an education setting. And it turns out that there's a number of different techniques that are employed. The other big goal for today is to just focus in and look at how testing, one way that testing can be done using Java tools, and those tools are called JUnits. So remember that we've reviewed the software development cycle, and most of the time when you learn programming, most of your time is spent here in the implementation. A good teacher or a good practice will have you spend a great deal of time here as well in making sure that you use pseudocode or algorithms to kind of design and ensure that you understand the requirements of the problem that you're working at. What isn't spent a lot of time on is testing, and that's really unfortunate because testing is an absolutely huge portion of programming in the real world. So there's an entire phase devoted to testing, and there's a number of reasons as to why we do that. And the first reason, quite honestly, is that we're not that good. Programmers make mistakes. In fact, when you look at statistics, it's about 15 to 20 errors per 1,000 lines of code, which is fairly significant. The other thing is that you have to remember that computers are not logically checking your code. They're checking your code for syntax. It won't let you run a program if there's syntax errors, but whether the program actually works, whether there are bugs that will allow someone to break into the program and thus break into the system, that's something that isn't just going to magically pop out. It's something that requires rigorous testing. Even in some of the programs you might do as a beginner programmer, if you don't properly think about your tests and plan your tests, you could be allowing bugs into that code. So the first thing I want to do is that being able to test code efficiently also means that you're following good programming practices. And one of those good programming practices is that you're actually utilizing methods. Because it turns out that modularizing your code into methods makes it so much easier to test, and therefore will make your code that much more secure and sound. And one of the useful tools of testing is to actually test at that modular or method level. You set a whole bunch of tests for a particular method, and then whenever you change something in your system, you can run through those tests, and it will automate the testing of each of those methods. And that kind of testing is called unit testing. And excuse me. You'll notice that kind of testing works well regardless of how you're designing and implementing, because at any point in the process you can go and test the methods that you have completed, and you can also test them in a hierarchical fashion. So when we talk about testing, perhaps it bears some help and some use to actually talk about what we mean. So on one level, testing means, does your code work 100%? Are there no flaws and no errors? In a practical level, that's not often what testing ends up being. I mean, almost every piece of software is released with bugs, sometimes intentionally. And so when we look at testing practically, we look at it at a couple of different levels. One is at the unit level. And by unit, I mean each functional part of your program. You can think about it as methods. Does this method work correctly? Have I rigorously tested it? Check. Next method. Check. The other part is you want to make sure that the pieces of your program work well together. So I might have tested a bunch of methods in this class and a bunch of methods in this class, but do the two classes work well together? Do the components of my project work well as a whole? So that's kind of looking at the overall program. And the last piece is the acceptance testing, which again is very often ignored, which is, does it actually meet the criteria for what you were supposed to have created? So in a course like this one, did you actually understand what your teacher was asking you? So that's kind of like the overall look at testing. When you drill down a little bit more, there's actually kind of two different levels of testing that you can perform. And they're called black box and white box testing. And they each have their uses. So black box testing is, if you think of, when you're in the dark, you can't see anything. So the idea of a black box is that you don't know or you don't care about the implementation details of that particular, let's say, a method. You don't care about whether, how many if statements or what the if statements look like, or did they use a switch, or did they use an if, or did they use a while, or did they use a do. That part doesn't matter. What matters is that you think of, what is this method supposed to do? And then you try to think of tests that will thoroughly test it based on its purpose, based on its use. So if you're trying to create a method to add two numbers together or to multiply two numbers, you don't care whether they directly multiply or added a bunch of times. What you care about is, what sorts of tricky tests might I have to give it that might mess up the idea of multiplication. Maybe you need to test zeros, maybe you need to test negative numbers, two negative numbers together, right? There might be certain key tests that you need to know of. White box testing is kind of the opposite of that. Rather than looking at whether it behaves as a whole, you're actually going to drill down and look at each path, each possible path or decision or loop in that code, and make sure at that granular level that there aren't little things that might be tricking up your code. So in many cases, black box testing is sufficient. But when you have a piece of software that's kind of critically important, that people are trying to find bugs and exploitations for, then going into that level of white box testing gives you that added security that there might not be something in there that isn't related to the functioning of the program, of that method, right? It isn't related to the overall purpose, but might still be causing bugs or problems. Here's a quick example of a black box testing. So I have a method, and it has a behavior. It's supposed to adjust the base premium based on some information, right? We've got age, sex, whether somebody's married, and that is, think of it like an insurance premium. Based on your age, your premium might go up or down. Based on your gender, it might go up or down. Unfortunately, those of you who are teenagers understand this, right? Males might get penalized more in insurance than females, right? Age plays a factor in accidents as well. And so the older you get, typically, insurance might go down. So if you look at this behavior here, you can think about, what sorts of key tests might you need to provide. White box testing, on the other hand, is going to look at the individual statements that are being done here. So it's looking at this if statement. It's going to try to thoroughly test the conditions of this if statement, and then it's going to move on. So it goes line by line, and you have to conduct proper testing. You can already imagine that this is going to be a much more involved testing scenario. Here's just the start of what it might be, right? I've got 3 different sets of tests I need to worry about in order to properly cover this. And just that first scenario, I have to worry about a number of different things that might happen, right? Your age is 23, which is less than 25, and you're male, and you're not married, okay? But now maybe you're female. And then now maybe, right? Maybe now you're older. So you've got to test the different conditions. You've got to test less than 25. You've got to test greater than or equal to 25. You've got, right? So you've got a number of different things. That's kind of a silly example, but that's kind of the level of detail that that testing gets to. Creating good tests is tricky, and as human nature is that you don't want to break your stuff. You made it. You're attached to it. You love it. And so that one of the hardest mindsets to get into with testing is that your goal is not to prove that you're an awesome programmer and that it's correct. Your goal in testing is to try to break it. And that's really tricky, especially when it's your own code, which is why often companies have people whose job it is to test, distinct from the people who are actually creating the code. Your purpose is to try to break it. You have to think of those cases that might trick up a programmer or a code or the behavior. The other thing is, I kind of hinted to this before, is that in theory, you'd be able to test it for every possible scenario. But when you're dealing with a real program, not something you might do while learning to program, but when you think of like Microsoft Windows as an operating system, it is impossible, just not practical, for them to test every single possible scenario. So the idea of perfect programs in the real world is virtually impossible at this point. Your goal then is to try to test as thoroughly and as intelligently as you can. So in Java, obviously there's many different testing methodologies or things you can follow. Java has a tool that is designed to sort of help you test at a method level. And that tool is called JUnit testing. And what I'm going to do is I'm going to kind of run through how that works and give you a quick demo. But the idea is that you can identify a particular method as being a test method, and the way that you do that is using that ampersand annotation that we've seen before. Ampersand at symbol. And then you can create a particular test. And that test always follows a particular format. It uses a certain method, and the method is really just has two parameters. One parameter, which is going to give you the desired result, and the other parameter, which is actually going to call the method and then take back the result from that method. And then, of course, what it does is it checks to make sure that the two are equal, and if they're equal, it gives you a thumbs up, you've passed. If they're not equal, it's going to give you a thumbs down and say, whoa, something's gone wrong inside this method. And that's essentially, it's way more complicated than that, but at its base level, you create a test, you use this method called assert equals, which is basically saying assert that both sides, both parameters are equal, and then it tests it. So here's a nice, easy example. Here I have a test. The test is going to test a method on powers. Assert equals that 4 is equal to calling math.pow to 2 to the power of 2. Right? So that would be a test that should, if the programmers who developed Java did their job properly, should assert and be good and give you that kind of thumbs up. Okay? So NetBeans. Those of you who are in my course, you'll have these slides, you can kind of walk through it, but what I'm going to do is just jump in and show you what the testing might look like in NetBeans. So here we are in NetBeans. Now, it bears mentioning that there is a bit of work that sometimes needs to be done to sort of set up the JUnit testing. There's a plugin that usually comes in and that usually comes with it already installed. But then you may also need to add in some other libraries, Hamcrest, for example. And so it's not something that JUnit testing really isn't expected of a beginner. But if you get to that point where you want to do it, this would be how you would set it up. And so here you can see I have a simple program. It's called Pirate. I didn't write it. In fact, I think I found it somewhere. I should probably remember where. But this is just a simple program that's going to keep track of a pirate. Pirate's name, how many limbs the pirate has left, as well as some other information. And let's just focus on, for example, the creation of a pirate. So when a pirate is created, it starts off with 4 limbs and a name. So if I wanted to test this, you'll notice that when I go to create new stuff, I can also go to other, and I can create a JUnit test directly from here, and I can give it a name. And you can see that that's exactly what I did. When I created the test, it came in here under test packages, and I called it pirate test, because the purpose of this test is to test my pirate. And so when I double click on that, it's going to take me to the class that was created for me to do the test. Now there's sections in here you don't really necessarily need to worry about. There's information about setting up the class or tearing down the class as a whole, setting up your tests, tearing down the tests. You can use them or not. For example, the setup is done before any testing begins. And so you can see I have decided to use it here, and I decided to create a new pirate. And I've decided to create a new pirate with a name, and that pirate starts off with 3 limbs. Arr. So then you can see that down here I've created a test. And notice what I've said is it has to always be preceded with this. That tells it that this method is actually going to be a test and that it should run it as a test. And then you give it a name that's usually meaningful to what it's testing. So in this case, it's testing the creation of a pirate. This first line is just an example that I gave you to show you that it works. And then this next one, well, let's actually make it fail on us. So remember, when I created this pirate, I created it so that it would have 3 limbs. And now I'm going to call this method, which is going to tell us how many limbs the pirate has left. And I'm saying it should be 4. So if I want to test it, I can either test from the project by right-clicking and going to test, or I can just directly say run this particular file here. So I'm going to run it. Oops, hang on, I'm kind of stuck. There we go. And you can see right here it says pirate test failed. And I can drill down and I can get some further information about why it failed. So failed, expected 4, but was 3. And so that's obviously a bit of a problem. And so now what I've done is really quickly, I didn't bore you with the details, but just to show you that you can have multiple tests in one class, is I've added another test here called test creation 2. Same thing above it. And this time it should give me a true result. And so if I go ahead and I run the test for it, you'll see it says 1 test passed, 1 test failed. And I can click on this other tab here and drill down a little bit, and you can see that it will show me that test creation 2 has passed. It'll even tell me how much time it took to run, but the test creation 1 still failed. So in a beginner course like the one you guys are in, do I expect you to go through the hassle of JUnit testing? Well, most teachers would say no, and I would as well. It's not really expected. What is expected is that you take your knowledge of testing, the idea of breaking the code, the idea of testing in a modular fashion, method by method, and that you apply that to the programs that you are running. So for example, if I were to give you a programming challenge where I want you to take a character, a lowercase letter, and I want you to shift that character by a certain number, and that's a method. Well, you now need to think of what sorts of things, think of it even from a black box perspective, what sorts of things do I need to worry about? Well, the character, if I said the character has to be a lowercase letter, then you need to do some testing to make sure that your method properly handles other things. The number, you will need to shift that. Well, most people might throw in a 2 and see if it works. What if it's a super big number, 1,000? What if it's a negative number? What if it's 0, right? Those are some of those key tests you need to run to make sure that the method behaves properly and that it doesn't break. And that's testing that is expected even at an introductory level of programming. So I hope this sort of overview of testing and one way that testing might be done professionally in Java kind of was helpful to you. There'll be some other lessons coming up soon. Thanks.